Hello all, I hope you are all fine and enjoying our channel. So, after the discussion of quantum mechanics and also the concept of orbit and orbital, I thought that why not we can proceed more of this atomic model. And in this regard, I thought that we could learn more about the configuration, how the electrons are arranged in the 3D space. So in this video I'll basically discuss about the electronic configuration. So now you can ask me that what is the important to know of this electronic configuration. So basically I will tell you that the electronic configuration is very important because by this way you can learn that whether the elements are reactive to each other or not, whether the elements are basically want to be in gaseous state or it should be present in solid state or in liquid state, what are the valence electron of the atomic model of any element. So the valence electron are reactive or not, whether it should form a inert gas or not. From this electronic configuration you could learn easily of this concept. So let's start with this video. Okay, so now we can proceed to the main content. So today's discussion is I will go through how to filling up the orbitals in an atom. Next, I'll discuss about the Pauli exclusion principle. Followed by it's also an important factor to discuss about the Hund's rule of maximum multiplicity. Finally, I'll go through the electronic configuration of atoms, and then I'll discuss a brief idea about the valence electron and the stability factor. So filling of the orbitals in an atom, so basically electron into the orbital or different atoms takes place according to the Aufbau principle. And this Aufbau words is basically comes out from the German's means, which is the building of or the filling up procedure electron in an atom, which is basically go through the Pauli exclusion principle, and it also obeys the Hund's rule of maximum multiplicity. Now here you need to know what are the Pauli exclusion principle and the Hund's rule of maximum multiplicity. So the ground state of an atom, the orbitals are filled in order to their increasing energies. So this is basically you need to understand that when the electron will be filled up in an atom, the lowest energy will occupy first, and then followed by the highest energy of the orbital will be filled by the electron. So according to that, I have put these numbers like 1s, 2s, 2p, 3s, and you can find in your textbook as well. So these are the orbital will be filled up one after another when the electrons are filled up of each orbital, right? Now how this orbital will be filled up by electron, that will basically discussed by Pauli exclusion principle and also the Hund's rule of maximum multiplicity. So in your textbook you also find that the electron will be filled up by 1s, 2s, 2p, 3s, and then 3p in this way. So people try to remember or recapitulate these things in their memory. So I will ask them, don't need to remember this sequence. You just write in your white paper n equal to 1 and then n equal to 2, n equal to 3, 4, 5, 6 this way. And then you need to write 1s, 2s, 2p, 3s 3p 3d, and 4s 4p 4d 4f, and so on. Next, what you will do, you will first drag a line in this way, 1s and then followed by 2s 2p, and then 3p 4s, and then 3d 4p and 5s, then 4d 5p and 6s, so on. So what does it mean? This means the arrow goes through top to bottom. So that means first the electron will fill up in 1s, then it will fill up 2s, then it will fill up 2p and 3s, then it will fill up 3p 4s, then it will fill up 3d 4p and 5s, and so on. Now here you can see I give an example of hydrogen atom. You can see one electronic atom, and here one electron is first occupied in 1s orbital. Then two electronic system helium, it will occupy 1s orbital of the two electrons. Next, the atomic number is lithium, it will occupy 2 electron in 1s. Then there is no accommodation can be provided by the 1s orbital, right? Because 1s, it can hold maximum 2 numbers of electrons. Then 1 electron will be shifted to the another orbital, which is 2s. Next, beryllium, which is the electronic atomic number is 4 and the electron is 4, so it will consist 2 electron in 1s, and the next 2 electron will be promoted to the 2s orbital. Now you have a brief idea how you need to fill up. Next, here I have wrote the interesting things, 1s, 2s, 2p. Oftenly these things will comes out in your examination. So how you can define if the orbital have the same number of n value or the principal quantum number is same? That means the electron have same energy level, right? Then how you will know which orbital will fill up first? So the only n value is not sufficient. You need to remember the n plus l value. The n plus l value is higher. That means the energy of the orbital is higher. N plus l value is lower. That means energy of the orbital is lower. So n plus l value is lowest, that will fill up fast, and then that when the n plus l value is larger, that will fill up next. That's why I wrote here. Here you can know the principal quantum number n equal to 1, right? And n equal to l equal to 0. So n plus l value equal to 1 plus 0 is 1. Next 2s, n plus l value is 2 plus 0, that is 2. So electron will occupy first, n plus l value is lowest, that side, right? So 1s will be occupied first and then 2s. In this way, here this is the major twist. You can find 2p and 3s. Here both n plus l value is same, right? Then which orbital will occupy first? The 2p orbital, because the principal quantum number, the n value is lower. That's why the 2p has the lowest energy than 3s. So 2p will be fill up first, then 3s. Now here I have shown you the orbital shape. You can see here the 3s orbital have the proper spherical shape, right? You need to also remember what is the shape of the p orbital. It is the dumbbell shape. And next you need to remember the 3d orbital, it's just double dumbbell shape, right? Okay, next I will now discuss about the Pauli exclusion principle. Pauli, according to this principle, no two electrons in an atom can have the same set of 4 quantum numbers, right? The Pauli exclusion principle can also be state that the only 2 electrons may exist in the same orbital, exactly right, and this electron must have the opposite spin. This means that two electrons can have the same value of three quantum numbers n, l and ml, but must have the opposite spin quantum number, that is designated upward or downward direction of the value plus of or minus of. The maximum number of electrons in the shell with principal quantum number n equal to 2n square, right? Now, Wundt's rule of maximum multiplicity. The pairing of electron in the orbitals belonging to the same shaft shell P, D or F does not take place until each orbital belonging to the subshell has got one electron each. That is, it is singly occupied. For example, I will give an example here. The oxygen atom 2p4 subshell is the last valence electronic shell, which is 2p4. Arranged, the electron is first upward, second upward, third upward, then another filling up which goes on the downward direction, not the upward, downward, upward and then downward, not upward, downward, right? So each electron will fill up first and then the next pairing happen in the another direction. This implies that if two or more orbital of equal energy are available, electrons will occupy them singly before filling them in pairs. Now the electronic configuration, how it comes out. So the electronic configuration of different atoms can be represented by two ways. One is SPD, this notification, and the orbital box diagram, which is designated here the SPD. This means the maximum number of electrons of each subshell can occupy it, right? So if you can consider the lithium, then you can see the lithium have the electronic number 3. So 2 electron here and then another electron is accommodated in 2s. Now how you can write? One is upward direction, another is upward direction. Next you will fill up this in opposite direction, right? In this way you will learn how to occupy the electron in different orbitals. The valence electron and stability factor. The highest principal quantum number are called the valence electron. The P3, P6, D5 and D10, F7, F14, etc. configuration, which are either half-filled or full-filled, are very much stable. The chromium and copper therefore adopt the D5 and D10 electronic configuration. That means D5 and D10 electronic configuration are highly stable due to the half-filled and full-filled electronic configuration. The electronic configuration of the known element determined by spectroscopic method. You need to remember these things. The ground state of electronic configuration of an atom or an element always correspond to the state of lowest total electronic energy. The electronic configuration must have atoms and follow the basic rules. However, in certain elements such as copper and chromium, where two subshell of differs slightly in their energies, the electrons shift to the subshell where the lowest energy is possible, and provided the maximum spin multiplicity, and it is filled by half-filled or full-filled configuration. Here you can see the chromium or copper is occupied the 3d5 and 3d10 is half-filled and completely filled configuration, not in d4 and 4s2, d9 and 4s2, right? It will first occupy the full-filled or half-filled configuration. In conclusion, N defines the shell, determines the size of the orbital and also the large extent of energy of the orbital. N means the principal quantum number. The maximum number of electrons in the shell with principal quantum number is equal to 2n square. The only two electrons may exist in the same orbital and this electron must have opposite spin by Pauli exclusion principle. If two or more orbitals of equal energy are available, electron must occupy them singly before filling them in pairs by Hund's rule. half field and full field configuration are very stable. So if you like our video, then must share, subscribe of our channel, and if you need any question, then you just drop your question to our email ID. Thanks a lot.